So yeah, in the Visual Learning Constructor 3.9, we have added quite a powerful tool or toolkit for for dealing with the bad columns. Because as you may know, yes, majority of the newest chips, they do have bad columns, and especially I'm talking about TLC chips and QLC chips and so on. They certainly have. Bad column is basically, you can find the article on our website, in our knowledge base. We do have explanation of bad columns, graphical explanation and so on. So I would certainly recommend it to go there and read it, and you will see the cause of bad columns, why they occur. But obviously, most of the reason is flash chips are in some way they are very similar to hard drives. Hard drives, they are not ideal as well. So on every disk out of factory, you have defects. And so bad columns are similar defects such as track defects, but they just call bad columns, right? So it's most of the time it's a vertical, vertical byte or 2 bytes sometimes, which go through all the plane. So basically, it's some sort of like weak places of flash memory chips. And so, because nowadays the technological process of memory chip manufacturing is so, it's so small now. The memory chips they made now, I don't remember exactly, like 16 or something nanometers now, the technological process, 16 or 17, and that's pretty, it's pretty small. And on such a scale, you cannot really control, control well the quality of silicon, the quality of the materials that are used for memory chip manufacturing, for lithography. And so, because of that, you're getting sort of like memory chips with the weak places. And of course, you as a user, anyone as a user of flash memory, nobody wants to get flash drive with defects. So nobody wants to buy a flash drive which doesn't work, right? And so manufacturers decided, okay, let's do an interesting thing. Let's do a trick. So let's just analyze the quality of chip using some specific statistical analysis methods, which we, by the way, also use now for bit column identification. So they basically analyze the chip byte by byte, like column by column, and they figure out which places are the weakest ones. So where they get more bit errors than in neighbor columns. And so by that sort of like a self-test of the memory or factory test of the memory chip, they do create some sort of table, let's say table of bit columns. Sometimes they store it in flash memory, like SanDisk, for example, do. But also, when memory chip is supplied to final manufacturer, when controller is connected basically to the board and to the flash memory, controller manufacturers, they also do some sort of testing or self-test of the memory chip. So they will also add their own bad columns. And as a result, when you're dealing with the chipo, when you get in device out of user or out of customer, you have like a bunch of bit columns sometimes, and there's no really like a special command that can pull out like all of them out of memory. There are some special commands that can help to extract part of bit columns, but not all of them, unfortunately. Right. So, and since the several and if you already dealt with bit columns, I do believe you probably saw how they look, right? In many cases, they look quite specifically. You can spot some sort of, whitish pattern. In some cases, you can spot darkish pattern. In other cases, like Elcor Micro, which is AU controllers, you can see pretty much nothing because bed columns are XORed, right? So on the top of bed column, they apply XORed. That's pretty, sometimes could be really frustrating to find them all. And one of the, but as you know, if you use Visual Learning Constructor, you know for sure that we have tool now. It's pretty good, actually, in my opinion. Well, I mean, comparing to other solutions or comparing to, removing them from hex or somehow manually. What we have now, it's not bad. You go through bitmap, you just hit the columns manually, but the problem is, it's time consuming, right? And our goal is not only to, as a vendor of the software and hardware, not only to support something, just support something, but also to support it efficient way. Let's say optimized. It shouldn't take so much time. And for me personally, and pretty much for any engineer here in our company, it's really frustrating dealing with those bad columns. And this is one of the you cannot start data recovery until you remove those damn bad columns, and that's pretty bad. Sort of like what really made us develop this tool as soon as we did, actually, it took like 1.5 months or so, is first of all, we got some documentation about the memory, and we have seen that for some manufacturers, when they supply chips, they claim that 45 bad columns, or 45 to 50 bad columns, I don't remember exact number, for one plane, that's a good number. So they utilize this chip as a branded chip. It could be any brand, right? And then if this number exceeds the 45 or 50, this chip becomes sort of like defective or doesn't pass quality control, and then it's getting sold to third-party small companies, and then they basically sell it or make devices with no-name chips. So this chip becomes basically no-name until you read ID, of course, right? And in such chips, we're getting like chips with 100 bad columns, right? Sometimes my probably Guinness record was I recently got a case where it was probably 300 or 400 or something bad columns for one plane. So that was really end of idea of trying to remove them manually. This is just a nightmare to remove hundreds of bad columns. You can spend like several hours, right? And so then we decided to okay, so we have now in Visual Learning Constructor, since the last update, we have added quite a very powerful platform, very flexible, adjustable platform for statistical analysis of the dump. We can do pretty much statistical analysis of anything we want now: blocks, dump, pages, particular columns, pretty much anything. And this helped a lot for bad column automatization. Basically, the tool we made, which I'm going to show you now, in 5 minutes, it's basically it's automatic tool, and for many cases you will get just clean result within just, I would say, 10 seconds, 15 seconds, 30 seconds, whatever. However, it doesn't work in 100% ideally, and you still have a very powerful tool set for adjustment, or for semi-manual, or let's say for purification of result, right? It's not that you have to go click and go to the end of page through bitmap as we did before, but now you can just simply group all bad columns together on the top, just quickly go through them within, say, 30 seconds, and understand which one to remove and which one to keep, because sometimes spare area may look like bad column, but you shouldn't get confused, because bad columns normally are statical lines, static vertical lines, when spare area does change in most of the cases. So, and as you can see here, it takes like 2 steps. First of all, we do statistical analysis of bytes, of every single byte in the page, and then on the second step, and we do like a soft decision. Basically, we just show you which bytes are most likely bad columns, and then you have to decide as a end user. You have to decide, or apply, or maybe check if you want some, or apply some particular filters in order to apply those bad columns, right? So let's go. Let's jump into the software. I don't want to look boring. Now, let's open up one of the cases, and those cases you guys have in Google Drive. So with the link which you got with email, you can download, by the way, the PDF file, and as well as those cases. Those are not the real size cases, but we just pulled out like 20 or 30 blocks out of every case, and you know, that's where we conduct bed column analysis. Let me open up the case. So I'm going to open now case number from bed column folder. It's going to be case number 1. Case number 1, which is this particular one is a Phison controller, but it doesn't really matter which controller is used. So this analysis is not exactly based on controller. Well, I mean, you can actually select preset defined for controller, or you can just use universal preset, which will work no matter what controller it is. All right, so I hope you can see the screen now. You can also, as I said, you can also open the case. It's going to be case number 001 or, well, yeah, 001 Phison or PS. It doesn't really matter which particular model it is. What we did, during the past sort of like months and a half after previous update, we analyzed a bunch of devices. We analyzed quite a huge amount of dumps, and we tried to group group solutions or automated solutions for bed columns divided by controller brand, and that's most in most cases it actually worked. So we created a special sort of like a plugins or filters for particular brands. So let's see how it works, right? So first of all, if you open a case, or you can look at the screen, I already have here a physical image, BCR element, ECC element, right? So here, the bed columns were already removed, and as you know, we kind of actually beginning now from the end, just so you understand how to check yourself, right? So in order to check if you removed bed columns properly or not, or if you removed all of them or not, you have to find ECC. You have to find ECC, and in, of course, huge majority of cases you can do. And so then once you find ECC and you look at the map, right, and if it looks green, that's all. Then you got it right. You got all bed columns removed. Well, I'll have another dumps. It's not going to be as green as this one, but that's just multiple times reread dump, and it's a purified dump here. So, anyways, that's it can be light green, it could be dark green. Doesn't matter much, right? So now let's go sort of like reversal way. Let's go back. So before ECC, we got this BCR, right? So first of all, let me show you interface. We actually try to keep it like it's really simple, and not to create something like completely new window, completely new interface, just to confuse people more. But we rather try to keep things simple and just kind of like adjust what we already have, so you can efficiently use it, and you don't need to learn from scratch how to use it. Yeah, so here nothing really changed. You still have to specify page size. Still have to specify, well, it's a sort of like predefined automatically actually, but the only thing you have to make sure you properly define is physical block size, because it's not always matching to what you have in memory chip configuration. I do believe Igor probably showed some of this on previous webinars, which you can find on our YouTube channel. And I think Igor will send the link later to YouTube channel. Make sure you subscribe if you didn't yet. So yeah, that's the only thing you have to control. Just keep in mind. We also have, as far as I remember, in knowledge base, some article that does explain what is a virtual block and what is physical block. All right, so let's click on the edit here, and there you go. You can see still quite a interface that you have seen before, as for those who already use this feature. And that's what we've been doing all the time, right? For most of you, I do believe it will look very familiar now, because you had to, go to the very beginning of the page, right? Press Shift and then scroll it all the way, step by step, till the end of page, which is truly frustrating. I can understand you. And then you had to, well, with the Control button, right, you can deselect bed column, and with the Shift, you can, you can select it, right? And so that's how it looked. Right? Then you can just, remove it if you did it wrong. But yeah, that's like, you have to go from the very beginning. You cannot miss any bed column, otherwise, nothing is going to work. You have to remove them all. And so you had to really, spend a bit of time, sometimes quite a lot, especially if it's 100 or imagine 200 bed columns. That's a nightmare. Yeah, so you had to go to the end of page just to see if there's nothing left that looks like bed column. Right? And then it's not the end, because you had to actually switch the plane, because you have to make sure you remove bed column from all the planes. Right? And then, well, obviously, as I think most of you know, it's the bed columns are not really same in planes. So, and they actually always different, right? So, and Igor saying now here in chat that it was very convenient. Old mode, it was very convenient as well, but we just did it better. Well, in my opinion, this one it was okay, but now it's really good. So, anyways, let me just remove all what we have here from both planes. And then we'll try to, well, create it now faster way. Right? So now, let's say we don't have VCC. That's how your, basically, you got physical image, you connected BCR, MC1, right? And you had set up your parameters here, which is a block size. Just, make sure you control block size. Then you hit on the edit button here. And basically, yeah, because it's a bit a new interface, and we are making now article. So yeah, it takes just 2 steps to remember how to use it. Right? So first of all, we have to select preset. Luckily, we made presets, special presets for statistical analysis of dump for different devices, for different brands. Right now, we keep it in files for a while until we move it to database. So here, what we have for now, the presets are working quite well. They're quite adjusted, but let's say if you get any case yourself where it didn't work so well, you let us know to support department, and we will fix it. We will adjust it, and we will see. So for now, I can go for universal. If I don't know controller, I can just go for universal template. But let's do it step by step, right? Let's try at first something that we more or less know. Right, so that's a Phison controller. I'm going to choose Phison preset. When you're done, you click read values. So basically, it's 2 buttons you have to, use. Select preset and then read values. So when you read values, that's where statistical analysis happens, and it does happen quite fast, as you can see. Right, so, but here's one important thing. For analysis, for statistical analysis, for now, we use only one block, so one particular block. So you have to make sure that you selected not empty block, right? You have to scroll down. Well, I apologize, in this particular dump, I don't have empty blocks because it's like just a chunk of dump, right? But in the real case scenario, you have to find the block at first, right? You have to scroll down, find the block, and then you just need to click somewhere, right? You click on the block in the bitmap, and you have here current block 4. But your statistics now is calculated for block number 0, if you remember. So when you click, just need to refresh values, read values, right? And now you adjusted, actually, you found the block with data, you adjusted it, and also you adjusted statistics. It didn't change here, but if you run this on completely empty block, it's not going to work, obviously, because you need data. to be analyzed. Yeah, basically here when I read values, we read the columns, right? So we read basically we read the block as a columns, right? And then we analyze every single column, what's inside this column, right? Of course, if you did manual bed column removal yourself before, you can probably remember how bed columns look like. But if you didn't, let me quickly show you. When you scroll down all the way, well, actually, let's go back to a physical image for a second. Right? So when you go through bitmap, through the page, that's what you see. Right? You see the shifted. You see, apologize. You see the shifted spare areas, and then you see those, inclusions. Unwanted inclusions, and those inclusions are exactly bed columns, right? So this is what we have to skip. This is what controller did skip, and that's what we want to, cut off the image and just get the data. So yeah, now I'm on block number 0 here. It's got a data. So I can use this one. So I need just to sort of like synchronize. I need to update statistics here. So now my current block 0. So make sure when I run this feature first time, make sure to find block with data first, right? Then click, just simply click somewhere. Click on the data, and then read values. But first you load preset, obviously. So load preset, click on the block, read values. That's all. And then what you got here is very interesting. And that's a new thing we added to this particular tool, right? It looks very little, but it's been a lot of work actually done and, to simplify and to automate it. But it all works in the background, so you're not overloaded with a bunch of information. All right, so what we did here is, so what's the idea here? So the main idea here is to point you to most possible, or to the bytes that are most likely look like bed columns. So selected items here are most probable bed columns. But you have to check them. But it takes now seconds, not even minutes, to to check them all. So what we did when you applied when you got statistics and applied preset and calculated statistics or read values, what we did is we detected all bytes that look like data bytes, and we said, okay, you don't need that. Let's unmark those and move them down, right? So you don't really get overloaded with a bunch of lines and rows and so on, right? So number of rows here, as you can imagine, equals to the page size. So the page size here is well, that's actually, see, there's 9 blah blah. It's not the last byte actually. Sorry. So the page size is 9216 here. So the last byte is obviously going to be 9215, which has been moved to the top. So here it is, right? So every line here represents one column. So in bitmap, it's column, right? In here, it is a horizontal line or 1 byte line. And so from this version 3.9 and further, we decided that, yeah, I will explain what this FFs mean. Sorry. So basically, every line here is 1 byte, right? So all the bytes that looking like data, we just moved down. You don't need those, right? You don't need to look at those. And from this version, and I think forever more or less, we decided to analyze the bed column size is going to be 1 byte now, always by default, because we analyze by binary statistics of bytes, not double bytes, because many of you probably know that in many cases bed column actually is double, the size is double byte, word or 2 bytes as you wish. And in this exact case, it is also 2 bytes, but we cannot analyze pairs of bytes because they may be shifted on the odd number of bytes from the beginning. So they not really stick well into pairs. So now this is what you're left with, basically. When you apply it preset, you read the values, and you're left with possible bed columns here. And for now, the first step was done, right? So that's just the first step. Right? Apply preset, move up all the bytes that look like bed column. So here you can see the flag. The flag means this. If you click right button, so there's some settings here. If you click right button, you can actually, you have a set of different operations and so on. Yeah, I see the question in chat. FF, what FF means? I will show you. I will show you what it is. Sorry. All right. So now, as most probable places for bed columns, you can actually. I would recommend it to always just have a quick look and understand how bed columns look in your case, right? Because in some cases, bed column looks like whitish pattern, like this one. You see, it's a whitish pattern, and as you can spot, it's double byte pattern, right? So you can tell for sure. Well, most likely, in this case, most of your bed columns, or maybe all of your bed columns, they're gonna look like 2 byte whitish things, so whitish verticals, right? And they could be actually different. As you see the values here, they're different actually, right? So some of them may have this strange things here going on, and some others, they could be very static, very straight vertical lines. But that shouldn't really bother you. You just need to understand in overall how bed column looks in particular case, because in other cases it's very easy. For instance, it could be just a single FF, right, or single byte FF byte, which is bed column, or it could be double FF actually, right? So just to have a quick look, try to find how it looks, right? So now I know here it looks like something white and something vertical, right? So I can quickly go now through the navigation. So you can navigate with mouse, or obviously you can just navigate with your keyboard arrows, right? And it's all synchronized by default, so you don't have to double click or hit any buttons to synchronize. It's just you just keep keep clicking, keep going down, and you can see yourself how this stuff looks like. All right, so this is just the first step we've done. Now, second step, I would call it post-processing, or adjustment, or purification of results, probably. So for now, the problem is, as you see, spare area also looks like columns, right? It's also vertical. It does change from time to time, but bed column can also change from time to time, right? So what do we do? I mean, if you just click here, add all bed columns, that's what we're gonna do in a bit, not so distant future, in 5 minutes. So you can add column one by one, right? But certainly it's not efficient, as you can imagine, because you normally want to add them all. So if you add them all, well, what happens is you're gonna actually add SA as bed columns as well, and that's pretty bad, because if you remove spare area, you got two problems. The first problem is ECC is not going to work at all. And the second problem is you remove spare area, so you cannot really, assemble logical image properly. So we don't want to remove spare areas. But luckily for the second step, we made here like a post-processing or like filters, right? You have special filters here. So let's just remove this stuff. Right-click on you can right-click on any bed column if you're doing the case with me. Click, okay, so first of all, these all filters will clean up, will clear selection. Right? So this all potential bed columns. But now we have to remove a couple of things from this potential bed columns. All right, so you can do clear used by type. So you can say, okay, I want to clear all FF. So FF is one, type of byte. So you can do that. So you can clear, clear by type, and all FFs are going to be removed. But let me just, okay, then you can set by type. You can, put it back, put flags back. Set use by type. All right, FFs. You can, clear all of the bytes for some reason. Or you can set all of them, again, for some reason. You can add some current byte as bed column, just one byte, or you can add all selected bytes as bed columns, right? So this is what means be selected. And here is one menu which has another level of menu. I think in a probably next update, or maybe we'll see, we'll probably add most frequently used buttons on the top menu on the panel, because there's plenty of space, as you see. But for now, we just really need to work with this feature for months to months and understand what is most frequent feature to use, and then we put them up. Filters. All right, so this is one of the really interesting part of the whole thing. So let me share you this document again, and I would recommend you to keep this one open while you're watching this webinar, because that's quite important, right? So we have several filters here. Some of them will exclude false positive bed columns, right? We call, false positive bed column a scenario when you have something else selected as bed columns. That's going to be false positive, right? And include missed bed columns. So this will, set flag on for the bytes that for some reason were missed, and they are real bed columns. Right, so two types of filters, basically, set flag and remove flag, according to some rule. And one of the rules here is, which is probably going to be most frequently used, clear use for chains. Well, here's the thing about bed columns. They never come in chains usually. Well, sometimes they do, like you can have 2 byte and then another 2 byte bed column, but that's more like exception. In most of the cases, bed column is just isolated, isolated line, and on the left, or your right, probably on the right, you have data bytes, right? So this is exactly what you can see in the case I'm going to show you now when we get back to it. Right? So clear for chains. You can see explanation here. The explanation of the filters. It will this one will remove selection from more than 2 sequential non-data bytes, which begins or ends on FF. So that's what we call a chain. You can also remove just a single FFs if you like to, if you need to, or you can include the opposite action. You can include additional byte as bed column. In many cases, we can find precisely, first or second byte of bed column, but we couldn't, precisely find the second one. And so this feature, set use for additional byte, it will expand selection, right? It will include second byte as bed column if it's not, if it's surrounded by data, right? Could be FF or anything else. And the last filter is to select XORed bed columns, because that's a hard subject, but in this particular version of software, it does work quite well. Not on all cases, however, but we'll get to it soon. So, all right, let's get back to the case. So now we have these filters here. So let's see. First of all, let's start. Obviously, you always start from the top. Bed column, the first one, 2 bytes, right? 848, 849. So how do you guys think? Is it a real bed column or not? 2 bytes. Just drop message to chat. What do you think? Real or not? Yeah, well, not. Well, well, actually it is. Yeah, it's you see, it's a 2 isolated bytes, which are surrounded by data, right? So this is data. I mean, even though it's XORed data or whatever data it is data, right? Data has high density, and this doesn't have high density of ones. So this is a real bed column. So this one we want to keep. So let's go to another one. So this one looks pretty much similar to previous one. So it is also bed column. That's a real bed column. So this is how bed columns look in this case. They look like a double byte, whitish, double byte, darkish vertical lines over the white space. So that's how it looks. All right, let's go further to another bed column and down to the some FFs. So this is also a bed column. Right, this one as well. There's a first byte of bed column and there's a second byte of bed column. And so here we got an interesting place. We spotted an interesting place here, which is actually, well, something. Yeah. So how do you think? Is it actually a bed column or not? What do you think? So, you guys can drop to chat. Yes, no. Is it bed column or not? Not. Huh. You nailed it, Alan. It's not. Yeah, Kevin, that's right. It's not. Why it's not, actually? Why not? I mean, it looks to me like a vertical line. Well, so why not? Any ideas? So basically, because first of all, for those of you who have some experience with the chip of recovery or with the visual non-reconstructor, you can probably recall the typical structures of pages, and this is certainly looks like a Phison like page structure, right? So it's got like 8 bytes of SA, and there's something that changes from block to block. You see, so these particular bytes, they would be SA. Right? And then they're surrounded by FFs, which is another sign of being per area. And this one was selected here as bed column. Well, why? Just simply because this is a vertical line. They also vertical. So that's the particular preset for Phison looks for something that looks like that. and yeah, so by mistake, or not really by mistake, because we did just one step and now we have to do the second one, it was detected as bed column. And also, if you scroll down all the way to the end, you're going to get a bunch of FFs at the end. Well, they also selected like, well, not bed column, but FFs, right? So do we need those FFs? Do we need to add those as bed column? Surely not, because this is not bed column. This is just, FFs. So, but can we actually use this, clear, FF filter? Well, we cannot, because this is not single FFs. By single FFs, we mean just, one FF surrounded by data bytes. So this is not surrounded by data bytes, obviously. So it is rather chain, we can say. So this thing is chain, right? It's more than 2 bytes of, same stuff which is no data, no bed column. So here we can actually apply filter clear chains, right? Clear use flag for chains. Click, and now you got this per area deselected, right? Now we have those bytes. Those are real bed columns. Those are two, right? And then we got seconds per area actually, and it's got deselected quite precisely. And then we got two other bytes that are actual bed column. And so you can see this is bed column, bed column. All right, looks like we got them all. You can just, just for keeping things organized, you can click on the header of the field here just to sort them one by one, but by selection filter. And now you can just, last time you can just go through all of them just to see, to make sure there's no SA selected or anything else. All right, so clean chain filter, which will probably use most of the time, will be used most of the time, and this will remove, anything else surrounded by, well, basically remove anything surrounded by FFs, more than two. All right, so yeah, okay, that's I think it's pretty much, this particular case is more or less clear. And well, now what? We selected them all, and those are all supposedly, bed columns. So now we just simply click on one of those, add all bed columns, hit all, add all bed columns. Now we got them here. Now we can go back to the workspace and check UCC map. All right, it looks green, right? But not all of it, of course, because as you may guess, we have removed bed columns just from one plane, right? And then there's another one. So, but I will leave you I will leave second plane for you guys to check yourself to find all bed columns, and eventually you will have to get perfectly green UCC map for every single block. So that's, guys, a homework for you for this particular case and for others too. So I'm going to show you several more cases, and I'll show you how to remove bed columns from one plane, and you can try yourself for the second plane. As you can see, this automatic tool is quite automated, but still, you have to. It does analyze every single byte and binary statistics of every byte. But you sort of have to control this artificial intelligence in order to not to let it decide everything for you, because it may not really work from the first step, and obviously it doesn't. Like here, it just won't work if you just select preset with values, add all bed columns. It's just not going to work. So you have to apply a little bit of you have to adjust it a little bit. So the second step, which is filters, that's what you have to take care of. But as you can see, I mean, as you can see, it's pretty fast now. So this is how it will look to me, or to any user who has more or less experience in the real life. So let me just remove them all. So for this particular case, I mean, sometimes case is harder, so it takes a bit more time to analyze. But now we have no bed columns. Select Phison preset, right? Read values. All right, just a quick check. All right, we have chains here, certainly, remove chain. Just in case, I would probably, sometimes not, sometimes yes, I would check, check bed columns real quick. Yeah, so I mean, it takes, as you see, for such case, like, for one plane, right? It's like, 15 seconds, 20 seconds, whatever. And then, of course, you don't have to every time, check it manually, just maybe faster to check the bitmap or ECC map, sorry, and make sure all bed columns removed. So that's, yeah, that's a, as Alan said, yeah, it's a big time saver for sure, right? So I think we're done with this particular case, and you guys try yourself second plane. That one is going to be quite interesting. So that's your homework. Let's move on to the next case. Again, just for demonstration purposes, we got here VCR as well as ECC. Yeah, as you see here, there's nothing was done to initial dump. So we got some bit errors here, and which will be in most of the cases successfully corrected with multiple reread with a retry. So let me just connect another BCR element just to show you everything from scratch. Right. I need to adjust this one to the physical block block size, and actually, let me show you real quick how to find your physical block size. Basically, physical block size equals to height of bed column. Right? Height of bed column is really easy to measure using bitmap functions. So click on the very first page of bed column, and then click on the last one. It's a 258. So physical block equals to height of bed column, right? It's a 258 pages here. And because your page size is essentially 90 to 16 in this particular case, so you can do a quick math. 90 to 16 times 258 is going to be, let me just quickly calculate it. It's going to be this. And here's another one, another parameter, which sometimes you have to adjust, just like in this case, number of planes, right? So the question is how to understand how many planes you have. That's fairly easy if you have bed columns. You simply need to understand how many, like, differently structured blocks you have. Or how many different offsets of bed columns you have. Look at this one. So this is one bed column, right? You scroll down and you don't see this bed column anywhere here. So that's another plane, because every plane has unique bed columns. And then you scroll up. So at least it's two planes, right? Then you scroll up, and wow, you see another bed column here, but it's like shifted, not like previous two. So at least we have three. And there's no three in the digital, digital electronics. At least it has to be 2 or 4. So usually it's power of 2. So at least we have now 4 planes, right? And that's fairly easy to check. Until you start to see repetitions of the structures, you can very easily understand how many planes you have. Right, in this case, it's going to be 4. So I will certainly adjust this one to 4 planes. And that's your parameters. They match now to what I had before. And now we click this edit button here. And we got a fresh fresh BCR, bed column remover. Now we select preset. It's going to be Silicon Motion now, because we know it is the same controller. Open. with values. And this one is interesting. You see, we automatically remove data bytes from bed columns. And now you're left with, well, a bunch of FFs, which are at the end, right? So from here, we certainly know that we should actually, remove chains here. Clean chains. And as you see, as you can spot, not only FFs were actually cleaned, but also something else, which has no type. So for now, as you see, we didn't assign the type to spare area because that's spare area here, and it doesn't look like bed column, neither as FF. So for this particular controller, for this particular preset, we don't define spare area, and so we can easily exclude it from analysis. And as you know, silicon motion controllers, they do have spare area at the end of page usually, right? So, and then the rest is just few bytes remain, really. You can see quite clearly, I think, this is also, something strange, some sort of inclusion. And that's certainly a bed column. You can compare it to another one. This one looks differently, but still, it kind of has the same density and so on. So this one is also bed column. But what is this FF? That's an unanswered question here. Could it be bed column? Well, technically yes, but most likely not. And in the majority of cases, it wouldn't be. You can kind of notice here, it does repeat every something like 1,000 bytes or something, which simply means this is, end of something, right? And in case of silicon motion controllers and many other controllers as well, this would be end of ECC. So as those of you guys who kind of experienced, you may spot yourself sometimes, end of ECC has, FF byte. So that's quite typical for silicon motion. It's kind of typical for some of the Phison controllers and some, other controllers. I have never seen it in SanDisk or some Elcor Micro. Don't use it usually. So yeah, most of the time it would be silicon motion if you see this vertical line. So you can see here, but anyways, it's a kind of like a sign for you that usually bed columns look, uniformly. I mean, they look similar everywhere, all over the place, all over the page, right? So this one would be bed column, FF. Well, it's not really bed column. So those are certainly bed columns. Again, FF. So we don't need to add this FF as bed column because it is not bed column, right? So, and most of the time, bed column is double byte actually, and we can clearly see this is double byte for sure. And then there's some weird stuff here inside, and some of them even completely blank, white, and that's okay. So we want to keep this, we want to remove this white, white lines, but we want to get, and we want to keep these dark areas, right? Dark verticals, because this belongs to, ECC. If you remove it, technically ECC will still work. So I mean, if you remove those FFs, it should be fine as well. But let's don't do that. So I can simply apply now. I mean, it's not so many as you see. You can just uncheck it manually, for instance. But I wouldn't recommend it to do so because it it develops bad habit. Because next case you have 100, 150 bed columns, and you don't want to go through all of them and manually deselect it, right? So right click, filter, clear flag for single FF. That's what you use. And those FFs are automatically, well, sort of like automatically removed. Now you just, for checking yourself, sort it by selection, go through it, and you can see it looks all right now. So now right-click, add all bed columns. They're all here now. Right, and then you can you can connect ECC, clear the map just in case. Open the map, and you get your first block green, right? And then obviously others are not as green as the first one because those blocks belong to 3 other planes. And so again, here, applying a very similar logics, you can, as your homework, you can try yourself to remove the rest of bed columns for plane number 1, number 2, and number 3. So that's up to you guys. No, certainly recommended to try it. All right, so that's pretty much all for Silicon Motion. Let me open another case. That's a really interesting one. We got 2 more cases. It's not going to take long time, I promise. Probably 15 more minutes, and we get a Q&A, quick Q&A session. Now let me open the case number 3, which is Elko micro XOR'd bed columns. That's really interesting one. So here we have now all bytes detected as data, yeah, because they all XOR'd. So what do we do here? So here we have a filter set use for XOR'd bed columns. Right? So in many cases, bed columns, XOR'd bed columns, it's like 2 bytes basically, or sometimes 3 bytes even. And those 2 bytes or 3 bytes, they have very similar statistics. They look very, similarly. And using that particular property, we can actually find just, pairs of bytes or triplets of bytes sometimes that look kind of, similarly. Now you can just organize them by, sort them by selection flag. So that's kind of important, thing here. You can sort them by pretty much anything, by type, by byte, and most of the time you're going to use this. If you want to basically move them up, just click sort by flag, and you get this here. And so here, that's how XOR'd bed columns look like. For those of you who are familiar, probably you'll see something that you're familiar with, and for those who are not very much familiar, that's basically how XOR'd bed columns look like. They look like 2, or in this scenario 3, very similar, but not always the same, by the way, so don't get confused. It's not like 50, 50, 50. Well, sometimes it could be, but in other cases, a couple of bits or 1 bit can be flipped or changed. And so then the hex value is going to be different, but statistically they're very close to each other. So we can spot them automatically here and, add them all as bed columns. And that's pretty much all. Right? So now we can go back here and check it. I might need to clean the map. All right. And as you see, yeah, because I didn't delete bed columns from other planes, from another plane, it's still all green. Yeah, but as you can see, let's say if you remove those, so map got updated, and you can clearly see one of the planes is completely red, right? And then as you add this bed columns, you turn it into green, basically. Just need to refresh it. Now it's all right. Okay, so that's how it works for XOR'd bed columns. Not always, I have to say. We're still investigating these XOR'd bed columns for subject of full automatization. Sometimes is more bytes selected than needed. So you have to go through them and make sure it's not false positives or it is, right? But still, it makes the process, especially XORed bit columns, makes it like, I don't know, 3, 5, maybe sometimes 10 times faster than it was before, right? So yeah, here's one really important thing you have to keep in mind or make a note or just remember. For XORed bit columns, never run analysis on XOR, on block with XOR. So here, it's not going to work as good as it worked on plain number 0. So you try it yourself later. So because this is a block with XOR key, and statistically, neighbor bytes are very similar, actually, right? So for XORed bit columns, we do not use blocks. It's kind of, like a paradox, because when we remove manually bit columns from XORed, XORed bit columns, we do use, it's better to use block with XOR because it's easier. When you use this automatic approach, you do not use block with XOR. So it's opposite, actually, right? So manual approach, you better to use a block with XOR. When you do automatic approach, avoid using a block with XOR. Luckily, majority of cases, it's very easy because majority of your blocks, they do have scrambled data, not the key itself. So it's going to be very easy to find you block without XOR. Not in this case, though. So, anyways, that's what sort of filter you have to use for XORed bit columns. It's just a specific filter for XORed bit columns, right? So now let me show you a last case which I prepared. It's going to be non-name device. It's some sort of unknown case, unknown. It could be anything. Monolithic device, pretty much anything. And of course, if you have a known device, you better not to use, specifically designed preset or plugin for a particular controller model. But you can use universal one. Right, let me share screen with you. All right. So hope you can see it. Let me resume. All right. Yep. Can you see it, guys, now? All right. Okay, so here we got, again, some, unknown device. We have page structure that was easy to find. So here, again, I have a, solved more or less. This case is pretty bad, will require a lot of reading. Probably I would go for 10 passes at least, depending on, situation. So here we do already have, just to show you how much work it will take by hand, you can see here all bit columns that were already removed. And the number is pretty, well, high. It's a 283 bit columns. And this particular job, if you do it by hand, well, you can imagine it'll take a tremendous amount of time. I mean, you'll have to literally go through every single byte and, you'll have to go through every single byte and remove it by hand, like every one of those, right till the end of page. However, as you can see, bit columns here look fairly simple. It's most of them are dark. Well, first of all let me remove all of those with the Control A. You can select it all and remove it all. Right. Yeah, it takes a bit of time sometimes when it's too many bit columns added here. So yeah, this is how, well, sometimes bed columns look like. So it's not always, as you can see, the algorithms that we develop actually took a bit of time. It's not, it's sort of like, it's got a little bit of flexibility. Let's say you can clearly see here is pure FFs, but here it's not. But our presets will actually include this one also as a, as potential bed column, because as I said, the algorithm is quite, well, I mean, it's not really any neural networks or artificial intelligence. It's not. It's a purely mathematical, statistical analysis. And we got some sort of complicated rules, what to include as bed column and what not. It's based actually on entropy analysis as well as statistical analysis. So anyways, so how do we remove all of those, bunch of bed columns? So I'm going to go for a universal preset. That's what you're going to use if you don't know which controller is. Universal one. So let's choose one of the blocks. Well, you can choose any one here. This, by the way, device has containing XOR key. As you see, it keeps repeating here. With values. And as you can see now, yeah, there's a lot of, all of those pretty much bed columns were actually selected. And yeah, you can definitely go through them. It doesn't take too much time, if you like to. In some places, you'll have even doubled bed columns here, like two together. And at the end of page, the strangely looking pattern, that's actually unused space actually in the page. But anyways, it was automatically detected and excluded from bed column. So basically here, as you see, we have selected FFs, right? And if you actually sort now by type, it's not only FFs that actually got selected, but also some unknown types of bytes, which are definitely bed columns as well, as you can see. See this small dotted column. Also, it is bed column as well. Right, so in this case, we have like the whole bunch of bed columns, and most of them are dark. Well, actually, most of them are FFs, and some of them just darkish, verticals with some pattern inside. And that's very easy to spot using this automatic, bed column detection toolkit. Right. So for now, you can obviously, right-click, add all bed columns. And can you still hear me, guys? Got some message that my mic got disconnected. So, can you hear me? Okay. All right. So yeah. So now we got this whole bunch of bed columns added, and just to make sure, just to control yourself. The easiest way, as I said before, to make sure that you got all bed columns, fixed. Just open a system map and check yourself. Yeah, as I said, this amount of bit errors here is quite quite high. But the main rule here is majority of pages. So this is sort of like a rule of majority. Majority of pages green. So bed columns removed properly, right? And then these red spots are bit errors here. It's not related to bed columns. So bit errors, bed columns is two separate things completely. All right. So yeah, you've got plane number 1 here, but unfortunately it's completely empty, so there's nothing to remove really. It's just a small chunk of dump, so yeah. So, but this one is certainly interesting. As you see, it's around 300 columns, and I would definitely recommend it to try, to try your hands on this one and on all cases we uploaded. We're gonna keep them in Google Drive for a while, so you can, still get it downloaded and keep it for future testing.